I want to solve the 1D heat equation with Dirichlet boundary conditions. I want an initial condition of a function that linearly ramps up between the domain of 0 and 1. Please write a MATLAB script that I can animate the solution as a function of time. I want the solution to go longer in time, to t equal to 5. Print out the whole script for me again, implementing these changes. Instead of a finite difference solution, I want a separation of variables solution using a generalized Fourier series. I want to compare the finite difference solution and the Fourier series solution overlaid on top of each other. Can you explain the stability criterion in a finite difference solution carefully for me? Can you write an implicit solution using finite difference? I want to compare that solution with the explicit method and the Fourier series separation of variables method. Can you make the figure axis with larger font and bigger features overall? Why did you make a mistake with the implicit construction earlier? I'm a student learning the 1D heat equation and its solution for the very first time. Can you describe step by step how you are solving it in all three different methods? You just jumped directly to the solution for the separation of variables Fourier solution. I want a step-by-step of how you got that analytical solution. This part was confusing to me. Can you explain it more carefully? Can you generate a LaTeX file that describes step-by-step all three different methods? Be careful in each of your derivations. I want to now solve the two-dimensional heat equation with Dirichlet boundary conditions on all sides, starting from an initial condition of 100 everywhere. I want to animate the solution on MATLAB as a function of time. I actually only want the separation of variables Fourier series solution for this case. I want a three-dimensional plot where the height is the temperature as opposed to a color contour plot. Please add a source term in the 2D heat equation. I want that source term to be sinusoidal as an egg carton in x and y. That's the initial condition. Actually, that's just the source term, not the initial condition. I wanted to start the solution from an initial condition of 100 everywhere. Why did you use finite difference? In this case, the source has sines and cosines, so it would make sense for the solution to also have sines and cosines. That makes more sense to me. I think your initial condition is wrong again. The initial condition should be 100. Did you forget our earlier conversation? Yes, implement this in MATLAB. This capability was not available when I was a student. I wonder how it feels to be a student with so much capability to learn, where the marginal cost of coding and the marginal cost of doing mathematics has reduced to zero or nearly zero. The promise and all the possibilities of science and engineering seem so much larger when the marginal cost of coding and the marginal cost of mathematics has gone to zero. It's an exciting time to be a scientist.